Hi, now let's try to find the resultant of more than two concurrent forces. So there are four steps involved in that. So now let's look into that. Step one. Step one is to find the algebraic sum of the horizontal components. So now let's try to find that. Okay, so this is in our first quadrant. We know that if the force is acting outwards from the origin, our sine theta as well as cos theta is positive. So let's try to draw this to positive just to remember so that we won't make mistakes. So our sine is cos is positive, our sine is positive. So the horizontal component is cos and the vertical component will be sine. So both are positive here. And so this is just to remember and to help you people so that you won't make any mistake in while doing the problems. So this side is your x is negative and vertical is positive. This side both vertical as well as horizontal both are negative. On this side our vertical is negative and horizontal is positive. So that we won't make mistakes while doing the problem. So now let's do the horizontal. Horizontal can be told as r, y in different ways in different books. They give different notations. So sorry, horizontal is rx, not ry. Rx is equal to it could be sometimes sigma fx, or it could be sometimes sigma h. So in different books you find all this way of approach. So we can take as say sigma fx is equal to f1. We have a force f1 multiplied by cos theta 1, and here our x minus f2 cos theta 2, here minus again minus f3 cos theta 3, and here when you come x is positive, which is our horizontal is positive, plus f4 cos theta 4. So this is your sigma fx. Now let's move on to the next step. Now we need to find the algebraic sum of vertical component. Let's look at it now. So that will be sigma. It could be r. Vertical component could be ry. Could be sigma v. It could be sigma fy. So let's do like this. Sigma fy is equal to, so again it's try to, until you are thorough with this, or even if you are thorough with this, if you practice this, you won't make mistakes in signs of vertical as well as horizontal components. Plus, so this side will be opposite, so that will be plus, minus, and this side will be both negative. Okay, so let's do it. So here we'll be finding the vertical component. So we need to multiply the force with sine theta. So F1 force is the first for this quadrant, sine theta 1 plus F2 sine theta 2 minus F3 sine theta 3 minus F4 sine theta 4. So this is our say vertical component. Now let's look at step 3. So now here for I'll explain how to do to find the magnitude of the resultant which we find. So we have our resultant R is equal to square root of sigma f x the whole square plus sigma f y the whole square. So the resultant we can find by taking the square root of sum of the vertical component as well as the horizontal component of each forces. Okay, F1, F2, F3, F4. So that will give, and this will give our magnitude. How much? What is the magnitude of the resultant force? We need to, if suppose we have to draw and show, we need to find the direction also. So suppose in the case of sigma fx is positive, we should draw towards right. I'll keep it as arrow. So you need to draw the resultant towards right. Suppose if fx is positive, sigma ffx, suppose if it is negative, we need to draw towards left. And suppose our sigma fy is positive, so we need to draw upwards. And sigma fy, suppose if it is negative, we need to draw downwards. Okay, so in this case, after finding the resultant, we draw for the positive sigma fx and sigma y. My y is this, my fx is this. So this we draw for the resultant. So now we need to find the angle. So that is our step 4. Step 4 is direction of the resultant force, or the angle we need to know. So that we'll find. So angle is found by tan theta x is equal to ry divided by rx. Okay. So theta x is equal to tan inverse of ry divided by rx. So this is how we find the theta of the resultant towards the horizontal. Okay, so if we look at the equation, so this is how it will look. So rx or sigma fx and ry resultant ry of the vertical component, or sigma fy is, and the resultant is rx square plus ry square, and tan theta x is equal to ry divided by rx, and theta x will be tan inverse of ry divided by